All right, let's dive into something pretty cool in the world of AI. We're going to talk about how a machine can learn to understand not just words, but the story they tell together. We're breaking down the tech that makes it all happen, recurrent neural networks, or RNNs for short. So, let's kick things off with a big question. Think about how you read a sentence. The order of the words is everything, isn't it? Dog bites man means something totally different from man bites dog. So how in the world does a computer get that? How does it understand that flow, that context? Exactly, and you've just hit on what we call the sequence problem. Honestly, it's a huge challenge. See, most of the classic computer models are built to look at data points like they're all separate, like individual entries in a big spreadsheet. But that's just not how the real world works, right? Not for language, not for stock prices, not for video. That right there is the key. In sequential data, what came before has a direct impact on what's happening now and what comes next. Every word in a sentence is building on the ones that came before it. So a computer has to be able to remember the beginning of the sentence to have any hope of understanding the end.
Okay, hang on a second. We're always hearing about how incredibly powerful neural networks are, especially for stuff like spotting cats in photos. So why can't those same networks just, handle a simple sentence? What's the problem?
That is a fantastic question. And the answer, in one word, is memory. A standard run-of-the-mill feed-forward network is completely stateless. That means it treats every single input as a brand new, isolated event. If you showed a picture of a cat, it has zero memory of the picture of a dog it saw just a second ago. Now, for static images, that's fine. But for sequential data, it's a total deal breaker.
So, if the big problem with the old way is this lack of memory, how do recurrent neural networks fix it? How do they actually learn to remember things?
They do it with this really elegant core idea, recurrence. You see, an RNN has something special built right into it, a loop. So instead of just pushing information forward and being done with it, it loops some of that information back on itself. This little trick allows the network to perform the exact same calculation on every piece of the sequence, all while letting information from the past stick around.
And this information that sticks around, this memory we keep talking about, it has a proper name. It's called the hidden state. The easiest way to think about the hidden state is just as the network's short-term memory. As it's reading a sentence, word by word, it's constantly updating this memory with what it's already seen. Let's just walk through how that works. So at the very beginning, the network takes in the first input. Let's say the first word of a sentence. It processes that word and creates an initial little piece of memory. We'll call that the first hidden state.
Okay, now for word number 2. The network takes in this new word, and here's the magic, it doesn't just look at it in a vacuum. It combines this new information with the memory it just created from the first word, that old hidden state.
And by blending that new input with the old memory, it creates an updated memory, a brand new hidden state. And this new state now has context from both the first and the second words. This whole cycle just repeats for every single word, carrying that thread of context all the way to the end. Okay, that flow totally makes sense. But what's actually going on inside that loop? At each one of those steps. Can we get into the nuts and bolts of it?
Absolutely. At every single time step, the RNN is doing 3 basic things, over and over. First, it receives the current input, the next word. Second, it updates its memory, that hidden state we talked about, using the new word and its old memory. And third, it produces an output for that specific step. It's really just that simple little dance. Input, update, output.
Now, if you want to get a little more technical, you'll see these specific symbols used all the time. The input at any given time t is called xt. The output is ot. But the most important piece of the puzzle is the memory, or the hidden state, which is st. And here's the thing. st is calculated using both the current input, xt, and the hidden state from the previous step, st minus 1. That's the loop right there in the math. Wow, okay, so the network can actually remember context. That feels like a massive leap forward. But so what? What does this actually let us do in the real world? What are the big applications for this?
Oh, this is where it all pays off. This ability to understand sequences unlocks so much of the tech we use every single day. Think about chatbots. They have to remember what you said 2 messages ago to have a conversation that makes any sense. Or sentiment analysis. It needs to read a whole product review to figure out if you liked it, not just look for the word good. And language translation? That's the ultimate sequence problem. You have to understand the entire thought before you can even begin to translate it.
This quote just hits the nail on the head. Without that ability to pass knowledge along from one moment to the next, you just can't get context. It's impossible. RNNs are designed from the ground up to solve this exact problem. They literally build a bridge from the past to the present.
And that really just leaves you wondering, doesn't it? If a machine can learn the patterns in language well enough to predict the next word, what other sequences, what other patterns can it learn? The ups and downs of the stock market? The notes in a symphony? The way weather systems develop? The possibilities are just staggering to think about.
And that's our look at recurrent neural networks. The ability to learn from sequences is such a fundamental building block for creating smarter systems. If this explainer helped clear things up for you, please do us a huge favor and hit that like button, share it with a friend, and subscribe for more deep dives into the tech that's shaping our world. Thanks so much for watching.